Okay, so hello and welcome to this video tutorial for E411 Statics and Dynamics of Simple Mechanisms. So we have this problem here that states the 70 Newton force acts on the end of a pipe at B. Determine A, the moment of this force about point A, and B, the magnitude and direction of a horizontal force applied at C, which produces the same moment where we're taking this theta here to take a value of 60 degrees. Just to save time here, I'm not going to draw all of the geometry onto our free body diagram. What I'm going to draw is this pipe, or just kind of the shape of the pipe. Looks something like this, doesn't it? And we can kind of infer that the geometry from the diagram we have here. Let's add our force, which is acting here. And we can say that it's acting 60 degrees to the horizontal. Okay, so I should say as well, it's got a magnitude of 70 newtons. Let's add that in here. Okay. So, as may have been described in previous video tutorials, we can understand forces as a sum of composite components, typically horizontal and vertical. So let's add these components to our diagram. Let's say this is our horizontal component of our 70 Newton force, and this is our vertical component. We understand previously how we can, or a quick kind of shortcut to break these down. We understand that we can represent the magnitude of this vertical component as 70 sine 60, and we can represent this horizontal component as 70 cos of 60. We can then use this as a framework to understand the moments acting about A, where A is this point here, point A. We can say, first of all, looking at the vertical and horizontal component here, if we're taking moments about A, imagine we're placing our finger on point A and that vertical component is acting. Which way would the paper be rotating? Well, it would be rotating clockwise, right? What about the horizontal component? Well, again, it would be acting clockwise, right? So both of these components here are contributing to a clockwise moment about A. We can show this notationally by saying capital M subscript A, and then this arrow to show clockwise is equal to the sum of the moment applied from the vertical component and the moment applied from the horizontal component. So in the case of the vertical component here, we're looking to multiply this magnitude by the direction from the point. And in this case, the kind of perpendicular direction from the point would be this length here, which when we inspect our diagram, we can see is 0.7 meters. So we can say from the vertical component, we have 0.7 times 70 sine 60 plus, and for our horizontal component here, that would be acting this distance away from moment A, and from our diagram we can see this is 0.9. So we can say plus 0.9 times 70 cos 60. Okay, and let me just check my notes here. And when we add this together, or when we bung this in our calculator, this gives us a value of 73.9. if we want to apply a unit to it, 73.9 Newton meters. Okay, so this is our moment about A. This answers the first part of our question. The second part of the question is saying the magnitude and direction of a horizontal force applied at C which produces the same moment. So what that's essentially saying is we want to apply a new force to our diagram here. So let me add this to our diagram. A new force about point C, which on our diagram is here. And what we want essentially is a anti-clockwise moment that is equal to the clockwise moment, which we know here is equal to 73.9. Okay, so we can say then MA counterclockwise is equal to 73.9 is equal to, well, in this case, we'll have a perpendicular direction from A of 0.9. So we can represent this as 0.9 times F subscript C, okay, where F subscript C is describing the magnitude of this force at point C here. And lo and behold, we have a solvable equation here, right? We can just rearrange this for FC. We can say FC is equal to 73.9 over 0.9. And again, let me just check my notes. This gives us a value of 82.2. 82.2 newtons here. Okay, so these are the solutions to our problem. If you have any questions or comments about that question, please feel free to leave it down in the comment section below. Otherwise, thank you very much for watching.